Okay, let's start our first question. Express each number as a product of its prime factors. First number is 140. So it is an even number. Start with the prime number 2. 2 sevens are 14 and 0. Then it is also an even number. So go with the 2 again. 2 threes are 2 fives are. Right? Now 35 is not an even number. It is also not going in 3 table. Then what is the next prime number? 5. So in the unit digit, of course, you are seeing 5. Right? 5 sevens are 35. Again, 7 is a prime number. Directly you can take 7 ones are 7. So what will be the answer? 2 into 2 into 5 into 7. Of course, you can write it as 2 square into 5 into 7. Right? Correct. What is our next question? 156. So same method, prime factorization, you have to write the answer in prime numbers. So 156. It is also an even number. So directly go with the 2 first. 2 sevens are and 2 eights are. Again even number. 2 threes are, 2 nines are. So 39 is not a even number. So how you find the even number? 0, 2, 4, 6, 8. These digits should be in the unit digits. Unit digits. Then only you can find it's a even number. So 9 is in unit digit. So it is not a even number. Check with the 3. 3 ones are, 3 threes are. 13 itself is a prime number. So 13 ones are. 2 into 2 into 3 into 13. We got all our prime factors. We can also write it as 2 square into 3 into 13. Next question. 3825. Check the unit digit. It is 5. Not 0, 2, 4, 6, 8. So 2 is not possible. Go with the 3. 3 is possible. Let's check. Okay. 3 ones are, 3 twos are, 7s and 5s. Okay, right. Again check with the 3 only. First check with the 3, then go with the 5 table. Okay. 3 fours are, 3 twos are, 3 fives are. Now in 3 table, it will not go. In the unit digit, of course, 5. Now go with the 5 table. 5 eights are, 5 fives are. Again 5 table because unit digit is 5. Okay. 5 ones are, 5 sevens are. 17 is a prime number. Directly 17 ones are. 3 into 3 into 5 into 5 into 17. You can also write it as 3 square into 5 square into 17. Okay. Next question. Zero, 5, 5005. So directly start with the 5 because in the unit digit, whenever you are seeing 5, 0, directly go with the 5 table. Okay. Now 5 ones are 0, 0, again 5 ones are 5. Okay. Now look at the 1001. It is not going in the 5 table also. So what is the next prime number? The next prime number is 7. So 7. Let's check in the 7 table. 7 ones are, 7 fours are, and 7 threes. Right. And then it is not going in the 7 table also. What is the next prime number? 11 is our next prime number. Right. 11 ones are and 11 threes are. Right. Now 13 ones are. 13 is a prime number. We know that. 5 into 7 into 11 into 13. Okay. What is the next one? 7, 4, 2, 9. Now it is not a even number. And also in the unit digit, there is no 5 or 0. First, let's check with the 3 table. It is not going in the 3 table. And then 7, not possible. So let's check in the 13 table. If possible, 13 table. Let's see. 13 table. If you do in the 13 table, it will not go in the 13 table also. So it's the 17, I guess. In the 17 table, 7429. Yes, it is going in 17 table. So in 17 table, 17 fours are, 17 fours are, yeah, it is going. 17 fours and then 17 threes and 17 sevens. So you know how to do the division. You can happily do the division. So you will get the remainder as 0. That's why it is divisible in the 17 table. Next, it is not going in the 17 table. Again the 437. So check in the 19th table. What is the next prime number? That is the 19th table, right? So 19 table. 19, 23. So 23 itself is a prime number. So 23 ones. So we can write it as 17 into 19 into 23. Don't not write this part. It is not required. Our next problem. Find the LCM and HCF of the following pairs of integers and verify that LCM and HCF is equal to product of the two numbers. Okay, let's do the first problem. If you take the 26, what are the factors for the 26? So if you do the prime factorization, you will get 2 into 13. So if you do the prime factorization for the 91, here I am doing. Okay. So in 7 table, it will go 7 ones are 7 13s are, right? You can write it as 7 into 13. So HCF means nothing but highest common factor. What is the highest common factor in these two? You can identify. 13 is the highest common factor. So 13 is the HCF. What is the LCM? So along with the HCF, what are the remaining factors? 2 and 7. So if you multiply all this, you will get the LCM. What will be the LCM here? You will get 182. So they are asking us to check LCM into HCF is equal to product of the two numbers. HCF into LCM is equal to product of the two numbers. What are the numbers? 26 into 91. Correct. So 13 into 182 must be equal to 26 into 91. So after multiplication, you can check. You will get it like 2633. 66 is equal to 2366. The first question is proved. 2366 is equal to 2366. What is the next question? 510 and 92. For the 510, if you do the prime factorization, in the unit digit, you are seeing 0. So, in 5 table. So, 5 ones are and then 0, 2's. Okay. Then you can do it with the 2 table also. 2 5's are, 2 ones are. Then 3 table, 3 ones are and 3 sevens are. Correct? So 510 you can write 2 into 3 into 5 into 17. Okay. Now for 92. If you do it for 92, the prime factorization, same method. It is a even number. First go with the 2 table. 4's are and 2 6's are. 2 2's are, 2 3's are. So 23 is a prime number. Now 2 into 23. Okay. What are the common? For HCF, what are the common numbers? 2 and 2. Except these 2 and 2, okay, there is nothing common in these two. If you go the LCM, along with the common numbers, you must write all the numbers, correct? So 2 into 3 into 2 into 5 into 17 into 23. So what will be the LCM here? You will get exactly of the multiplication 23,460. So HCF into LCM, HCF into LCM is equal to the above numbers 510 into 92. So what is the HCF into LCM? So you can write it as 23,460, which is equal to, 2 into 2, which is equal to 510 into 92. So it will be 46,920. Definitely this must be equal to 46,920, which is also equal to 46,920. Okay, so this will be proved. You do the multiplication, you will get the answer. So what is the next question? Our next question is 336 and 54. 336 and 54, right? So what are the factors for 336? Check with the prime factorization method. So you are seeing directly 1 1 2, right? Again go with the two tables. So actually start with the two table, but directly you can see all of these are the numbers which can go in the three table. So that's why I chose 3 first, but always choose the small number first. 2 5s and 2 6s. Again the even number, 2 2s, 2 8s. Again even number, 14s and 2 7s. Right? 7 is a prime number. So now tell me what are the factors for this? For 336 you can write 3 into 2 into 2 into, how many 2s are there? 4 2s. 2 into 7. So you can also write it as no need, because you have to find out the common factors. 54. For the 54, if you do the prime factorization for the 54, again even number, 2 table, 2 2s, 2 7s. Now 3 table, 3 9s, 3 3s, 3 1s. Okay. 2 into 3 into 3 into 3. What are the common in these two? Here you are seeing 1 2 1 2, 1 3 1 3. So can we write the HCF now? HCF is equal to, what is the HCF? 2 into 3. Only two factors are there common. What is the LCM? Along with the common factors, write down the remaining factors. These things and here. 2 into 3 into, 2 into 2 into 2 into 7 into 3 into 3. Okay. If you multiply all these factors, you will get answer as 3024. Okay. Now we have to check whether the multiplication of LCM and HCF is equal to the product of 336 and 54. Let's do. HCF into LCM must be equal to 336 into 54. So what is the LCM? That is, first HCF. What is the HCF? 2 into 3, which is 6, right? So 6 into 3024, which is equal to, if you multiply these two, you will get the product as 18,144. So here also you will get product as 18,000, if I'm not wrong, 144. Right? Hence proved. What is the next question? It is very easy question when we compare it to our previous questions. Third question, find the LCM and HCF of the following integers by applying same method like how we did the previous questions, prime factorization method. So same thing you can apply here. So first find out the factors individually for each term. 12. So for the 12, what are the prime factors? 2 into 2 into 3. For 15, what are the prime factors? 3 into 5. Right? For 21, directly 3 into 7. So if you see it carefully, you can find HCF. What are the common factors in these three numbers? 3 is the common. So what is the LCM? Least common multiple of these three. LCM is, along with the 3, Write down all the numbers. So, I mean 2 into 2, 5 into 7. So, along with 3, the common number you have to take only once. The remaining numbers you can take 2 into all the numbers. 2 into 5 into 7. So, if you do 3 into 4 into 35, which is nothing but 12 into 35. Okay. Here I did. Here. Then 3 4s are 12. Now, 12 into 35, you will get after multiplication 420. Now, for the 17. 17 is a prime number. 17 into 1, 23. 23 is also a prime number. 23 into 1, 29. It is also a prime number. Why we call all these as prime numbers? Because it has only two factors, 1 and itself. So, then we call these numbers as prime numbers. Let's see. What is a HCF? There is no common factor. If you think there is no common factor, you'll be mistaken. There is a common factor. If you are not seeing any other common factors, directly your HCF will be 1. LCM is equal to, along with the 1, right? 17 into 23 into 29. After doing multiplication properly, 11,339 will be your answer. Right. What's the next problem? 8, 9 and 25. Let's do it individually. For 8, 2 into 2 into 2. Of course, we know 2 cube is equal to 8. For 9, yeah, 3 square is equal to 9. 3 into 3, 25. So, all these are, I think, perfect squares and perfect cubes. You can find the prime factors easily in it. What are the common in these three? Are you finding any common in these three? No. So, if there is no common factor, directly your HCF will be 1. What will be the LCM? Write down all the numbers. Okay? Write down all the numbers. 2 into 2, 3 times you got. 3, 2 times. And 5 also 2 times. Directly multiply all the numbers 8 into 9 into 25 because there are no common factors to write the factor as one time, only one time. 1800 will be your answer after the proper multiplication. That's it. What will be the next question? Given that HCF of 306, 657 is equal to 9. Okay, find LCM of same numbers 306 and 657. Right. So first write down the given data. What is the HCF? They are telling HCF is 9. We don't know the LCM. We have to find out. What are the numbers we do have here? Numbers are 306 and 657. Correct? So what is our common formula? We were using it. HCF into LCM is equal to 306 into 657. Okay, what is the LCM here? We don't know the LCM. And HCF? Yes, we know. 9 into LCM, which is equal to, after multiplying, or else you can directly cancel. 306 into 657. So, if this 9 goes to right side, it will become denominator. Because in the left side it is in numerator, right? I hope you all know the basics. 306 into 657 divided by 9. So, in 9 ones are, and then 9 threes are, 9 fours. So, LCM will be 34 into 657. After doing the multiplication, you will get the answer as 22,338. 22,338. Let's go to next question. Check whether, sorry, it is a mistake. So, just change it. 6 power n. Check whether 6 power n can end with the digit 0 for any natural number n. right? So to be end with 0, definitely it must have factors as 2 and 5. So if you consider this 6, what is the prime factorization? 2 and 3 and 1. Correct? Huh? So you have only factors as 6, 3, 2 and 1. So if it is end with 0, it must have factors as 5. Yeah, it must have one factor of 5. So it doesn't have any factor as 5. The prime number 5. So 6 power n can end with 0, can end with 0 if 2 and 5 are its prime factors. Prime factors. So there is no prime factor of 5. Yes, we do have prime factor as 2, but we don't have 5. So since 5 is not a prime factor of 6, therefore 6 power n cannot end with 0. You can also check it in another way, like 6 power 1 is equal to 6. 6 square is equal to 36. 6 cube is equal to 260. 6 power 4. Again, you will get unit digit as 6. You never get the unit digit as 5. You never get the unit digit as 0 or any other number. You always get the unit digits as 6 only. I hope you understand this method also. But no need to write this method in the exam. Till here, it is enough. Answer from here to here, enough. Sixth question is, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5, right, are composite numbers. Let's take the first number as 7 into, I'm taking this as, consider this as A. Let A is equal to 7 into 11 into 13 into, 13 plus 13. Okay. So give brackets. I hope you all know the BODMAS rule. So in these two, there is a common number, which is 13, right? 7 into 11 into 1 in the place of 13, you write the 1 because you are taking the 13 out. Okay, next 13. This is 17, 7 plus 1, which is equal to 13 into 78. If you consider the 78, it is a composite number. Okay, what are the factors for this 78? Go with the 2 table. 2 3s are, 2 9s are. Now 3 table, 3 1s are, 3 3s are. So 13 into 2 into 3 into 13. It is a prime number. Why? Because it is having more than 2 factors. Proved. So what is our second number? Our second number as B. B is equal to 7 into 6 into 5 into 4 into 3 into 1 plus 5. Again give brackets. Place the plus symbol in between those two. Right? What is a common number in these two? I can see 5. 7 into 6 into 1 into 4 into 3 into 1. Okay? And then here also you just give 1 because you took the 5 outside. 5 into In the brackets, first you multiply all the numbers. 7 6 are 42. 42 into 12. You will get 1008 plus 1, which is also equal to 5 into 1009. So here you can see 5 into 1009. Again same. More than 2 factors. Along with the, so what are the factors we can see here? Along with the answer, you can have 1, 5, 1009 and the answer. Here you will get some answer, right? So you are seeing many factors here. That's why it is also a composite member. What is the next question? There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Right. We don't know how much time they took to meet at the starting point. We have to find that. So, Sonia took 18 minutes and Ravi took 12 minutes for the same distance. Suppose they both start at the same time. They're telling they started at the same time, same point also. Same time, same point. So we can, and also they are going in the same direction. It is not needed that much. Okay. After how many minutes will they meet again at the starting point? They have to meet the starting point again. So we are seeing the hints clearly. They're asking us to find out the minimum time. So the minimum time they will meet become the LCM is the least common multiple, common time. The same time is nothing but the common time. So you can take the least common multiple of 12 and 18. I hope you understood this point, important point. Okay, so for the 12, if you are taking the prime factorization, so you know from here you know how to do the LCM. 2 into 2 into 3. Do it with me. 18 is equal to 2 into 3 into 3. So what will be the LCM? First you take the common numbers only one time, 2 into 3. So the remaining number you can take directly. Again 2 into 3, which is equal to 36. Therefore, the main point, last point is very, very important. Whenever you are writing the exam, please note down. The last point is very, very important. You must write down the therefore, and your conclusion. Okay, after that, Sonia and Ravi meet at starting point. After how many minutes? After 36 minutes. By this problem, our first exercise is completed. I hope you understood this class. I hope you enjoy this class. We'll meet in the next class.